Next is the asteroid belt. And that's just basically made up of millions and millions of rocks orbiting between Mars and Jupiter. And you can see they're scattered mainly in a particular area, but scattered all around that asteroid belt. The largest one is Ceres. Compared to the Earth, it's tiny. That's the biggest asteroid there is. So it's nearly 1,000 kilometres across. So it's a rock that would stretch from Melbourne to Sydney. So it's still a pretty large piece of rock. But that's the largest asteroid. About 1/3 of all the material in the asteroid belt is in that one rock alone. So the rest of the asteroid belt, all these other little dots that you saw before, put all those together, it only makes a rock twice that big. So you put everything in the asteroid belt together, you would get a planet about that big compared to the Earth. So much smaller even than the Moon. So there's a lot of bits out there, but they don't add up to very much. There's sometimes these rocks, of course, like those meteorites from the Moon, can crash on the surface of the Earth, creating a crater. This is a well-known one in Arizona. From one side to the other, this is 1.2 kilometres. That was made by a rock around about 40 metres in diameter. So 3 or 4 times the size of this building makes a hole in the ground more than a kilometre across. This is my piece of meteorite. And I call him Aussie. Hopefully you can see why I call him Aussie. And he landed in Argentina around about 6,000 years ago. And he's made of almost pure iron. It's about 96% iron. Most of the remaining percentage is nickel. We've also got another smaller piece in this tin, which I'll get out later too, which is a piece from the same meteorite. He weighs about 11 kilos, so when you pick him up, you need both hands. It's much heavier than you think. So you need to get a good grip. You don't want to drop it on your toe because it's iron, it doesn't bounce.
How do you date a meteorite like that?
You buy it on the internet. Again, not from
No, date it.
I date it.
Yeah.
They can date it by, because when the meteorite's up in space, there's nothing to oxidise it or change it chemically. When it lands on the ground, they can look at how the chemistry has changed, and they can estimate how much it's aged, basically. So like a person, you can look at a person and you can sort of look at them and guess, and I can say, look, you're probably about 21, something like that.
So it's the deterioration since.
Yes, you can see the deterioration. It'll rust away at a certain rate, like everyone does. And so you can estimate how old they are by the amount of rust and how much it's been oxidised from the oxygen
You're
and
going
stuff.
to be WD-40.
So that's how they can work out how old those sorts of things are. Now we move on to Jupiter. You can see why I don't have a scale model Jupiter. Where basically I'd have to lift the roof to fit it in. It's about 11 times bigger than the Earth. So 11 Earth will go across there. The red spot is a little bit larger than the Earth. You've probably all heard of the Great Red Spot. When you look at it through a telescope, and you'll see it tonight, Jupiter is around about there somewhere. You'll see the really bright star out over there, that's Venus. Jupiter is out over there. You've probably seen at least Jupiter for the last couple of months. Venus is only starting to be visible sort of recently. But when you look at it through a telescope, you might see these couple of dark bands, and you'll possibly see 4 bright dots nearby, and they're the moons, the 4 biggest moons of Jupiter. You can see those moons even in very, very small binoculars. You don't need anything particularly big to see them. They're actually visible with the naked eye, but because Jupiter is so bright, you can't see them because they're so close to this very bright planet. Now, Saturn is the next one, and we all know what's so great about Saturn. The rings, exactly. It's best known for its rings. some people won't remember records, but it looks like grooves in an LP record. There's thousands and thousands of rings. Unfortunately, CDs don't have rings. So people will have to think of something else, I guess, when people go, what's a record? So you can see here all these thousands and thousands of rings, and they're made up of tiny little bits of ice. Maybe the biggest might be the size of a refrigerator down to tiny little specks of dust. And it's nearly 10 times bigger, so it's a little bit smaller than Jupiter, so about 10 Earths almost will fit across there. The interesting thing about Saturn is when you look at it in an eyepiece, it's the only planet that looks like its pictures. You see pictures of Jupiter and you've got this lovely red spot and all these swirls and stuff. In a telescope it looks nothing like that. The red spot is just a murky, sort of a darky brown colour, if you're lucky enough to make it out. Saturn, when you look at it through a telescope, you will actually see the rings, and you might see, well, you will see the yellow coloration. You'll see maybe just out near the edge there's a little dark band, what they call a gap in the rings, where there's actually no material. So Saturn actually looks like its pictures, unlike virtually everything else you'll see tonight, but you won't see Saturn. Saturn comes up maybe 2 or 3 o'clock in the morning at the moment. In a few months' time, later next year, you'll actually see Saturn, and it'll be a definite yellow colour. But you've got to wait till next year before you can see it at a decent time. Uranus, the next planet out. If you look at it through a telescope, it just looks like this, only quite small. Boring, just has very faint, sort of smudgy colour. We move to Neptune, which is the last planet. But just because it's last, it doesn't mean it's the least. Because if we compare Neptune to the Earth at the same scale, there's the Earth. Now this is the smallest of the large planets. That's how big Neptune is compared to the Earth. So you can see that even though it's the smallest of the big planets, it's still much, much bigger than the Earth in comparison. And you think it's a long way to fly to London. You imagine if we lived on a planet that size, flying to the other side. Even in an aircraft, it would take you several days, rather than 24 hours or so.
Can you see with the naked eye?
Not quite. You can see Uranus with the naked eye, barely, but you really have to know where it is. Neptune's, you can't quite see it. You could see Neptune with a pair of binoculars if you know exactly where to point it. But when you look at it through a telescope, it's just this little blue dot.
So the ancients didn't know that?
No. They may have known about Uranus, but because it's so faint, they would never have registered, and it moved so slowly, they wouldn't have registered that it was anything other than a green sort of star, because it was so faint. So it's a little bit smaller than Uranus. It's about 4 times the diameter of the Earth. So how do they compare if we have our little Earth here? We put all the other planets at the same scale. You can see how they all compare in one picture inside. But because they're different sizes but different distances, some of the planets are quite large, like Neptune, but it's a very long way away. And Venus and Mercury are fairly small, but they're quite close. So if you could look at all of the planets in an eyepiece of the same telescope at the same time, they would actually appear like this. So you would see that through a telescope at the same magnification, Venus appears to be slightly bigger than Jupiter, which is only because it's so much closer. And Jupiter is much, much bigger, but so much further away. And Neptune would just be, as you can see, quite a small, pale blue dot, and Pluto would just be basically a star. So what about Pluto? Well, Pluto's not a planet anymore, which is why we didn't count it in with the planets. And if we look at Pluto at the same scale as the Earth, you can see it's not as big as the Moon. It's maybe half the size of Australia, but quite small compared even to Mercury at that same scale. If Pluto was still a planet, at the moment we have the planets go like this, and there used to be Pluto down the bottom. But if we changed it, so, yes, you've got a question? Sorry? No. Pluto is so cold, the atmosphere, they believe it's got an atmosphere of nitrogen. Most of the time it's so cold the nitrogen is actually ice. So the atmosphere, most of the atmosphere of Pluto is frozen solid on the surface. But they know it has an atmosphere, and they think it's probably nitrogen, but frozen nitrogen most of the time, because it's so cold up there. So if Pluto was still a planet, then it's possible these other objects are as much a planet, if you like, as what Pluto is, which is why they've termed a dwarf planet for Pluto. So if we were to call Pluto a planet, we'd probably have to call all the other dwarf planets planets. So we'd end up with not just Pluto, but Haumea, Makemake and Eris, because they're around the same sort of size and have the same sort of characteristics. But there's also, this is 13, but there's also others, which when we know a little bit more about them, they may actually also be the same sort of category as Pluto. So we may actually end up after Neptune with Quaoar, Orcus, Pluto, Haumea, Makemake, Eris, 2007 OR10, great name, and Sedna. So we could end up with that many. 17 planets. But there's more. Astronomers speculate there's possibly 50 more objects out there that are a similar size to Pluto. That if we call Pluto a planet, we might have possibly as many as another 50 more that should be called a planet. If we call Pluto a planet, we're going to open the floodgates. And we'll have to remember all of these. 67 planets. I'd rather remember 8, it's a lot easier. Now, we go out tonight and you'll see the stars up there, and you'll notice if you're out there for a while that the stars will gradually move. If you were to open the aperture of a camera and just let it expose the stars for a few minutes, you'll see these trails. Yep.
When Pluto was a planet, and when they took it away, why did they choose Pluto to be a planet and not the other ones at the same time?
Because the other ones were never planets anyway. And when they discovered Pluto, they had no idea about all these others. And then after they discovered Pluto, they thought that's a planet because it's all out there, all on its own. And then in the last maybe 20 years, they've discovered more and more and more. And there's all these other objects. Many of them are much the same distance as Pluto. Some of them are even bigger than Pluto. Some of them are the same distance, similar orbit. And then it's like there are all these others that we didn't know about. So that's one of the main reasons they had to change the definition for Pluto, to demote it, because otherwise they just saw we could have 60 planets easily and keep discovering more. So the stars appear to turn because the Earth is turning. So the stars that are overhead now at a particular time will be overhead 2 hours earlier. So say 9 o'clock tonight, there'll be some stars directly overhead. 2 hours earlier next month, so at 7 o'clock, those stars will be directly above again. So at the same time, they'll be a little bit further around. So the stars slowly walk around throughout the year, which is why